Hello my friends, I welcome you back for this series of programming concepts using C. For those of you who have begun with this video, I'm urging you to go and find the first two videos that were talking about the introductory concepts. I'm Hudson Nandere Luvinga, I'm a programmer, I'm an instructor from Uganda. My contacts are there and my email, so you can easily comment, you can easily ask a question via the email, via the comment, and I can reach out to you. Don't forget to subscribe to my channel and don't forget to invite other members. Let's pray. Kind and loving Father, our God Almighty, thank you, Lord, for helping us reach today when we are still alive. Bless us in everything. Give us knowledge and understanding in what we are going to study, for we pray this, trusting and believing in the mighty name of our Lord Jesus Christ. Amen. Today, we are going to look at the C fundamentals. Let's begin with the C character set. As every language contains a set of characters, even C has what we call the character set, and this set of characters helps us to construct words, statements, and many other things. So the C language also has a set of characters, and these include the alphabets, the digits, and special symbols. The C language supports a total of 256 characters, and every C program contains statements. These statements are constructed using words, and these words are constructed using characters from the C character set. So when you get words, you combine them, you form statements, and when you combine several characters, you construct words. So C also has got a set of characters that has alphabets, digits, and some other special symbols. So we have the alphabets. The C language supports all the English alphabets, both the lowercase and the uppercase letters. So the C language supports a total of 52 alphabets. The lowercase letters are from small a to small z, whereas the uppercase letters are from capital A to capital Z. And now C also supports digits. It supports 10 digits, which are used to construct numeric values. So these digits range from 0 up to 9. Then it also has special symbols. This C language supports a rich set of special symbols that include symbols to perform mathematical operations, to check conditions, white spaces, box spaces, and other special symbols. So you can see those symbols here. These are the digits. We have the alphabets. So all these constitute what we call the C character set. So we have one exercise there. You are required to write a simple C program to print or to display all the characters of the C character set. So make sure you make some research and get to know all the characters as you have noted them, and your program should be able to display all of them when it is executed. My friends, that's an exercise. Try it out. Let's talk about the tokens in C. A C program consists of various tokens, and a token is either a keyword or an identifier, a constant, a string literal, or a symbol. For example, this following statement consists of 5 tokens. So you are seeing a statement here, printf hello world. And these are the individual tokens that are derived from this statement. The first token is printf. Remember, token can be a keyword, so this printf is a keyword. A token can be a symbol, so you are seeing this symbol and this symbol, those are tokens. A a token can be a string. So this hello world is a string. A string is identified by seeing the quotes. So when you say word enclosed in quotes, that is a string. And then we have the terminator, the semicolon. So we have 1, 2, 3, 4, and 5 tokens in that C statement. We have semicolons. In a C program, the semicolon is a statement terminator. That is, each individual statement must be ended with a semicolon. So the semicolon will indicate the end of one logical entity. For example, we have these two statements here, and this semicolon separates them. So when you say semicolon here, it shows that this statement ends here, then you have another statement, and we terminate or we end it from there. So we have these two statements. What about comments? In a C program, the semicolon is a statement terminator, as I have already said. And each individual statement must be ended with a semicolon. So we can also have a comment. A comment will always be enclosed in the forward slash followed by the asterisk, and then you have another asterisk, then you end. So this is a comment, and this comment cannot be executed. The compiler will just ignore the comment. The C language uses a compiler, not an interpreter. You remember we talked about translators. We have compilers, interpreters, and assemblers. So the C programming language is compiled. It's a compiled language, so it uses a compiler. Now this comment you're seeing here can even work on multiple lines, but again we can have another comment for only a single line. We can prefer using this kind of comment where we have the double forward slashes. Let's talk about identifiers. A C identifier is a name used to identify a variable, a function, or any other user-defined item. An identifier starts with a letter capital A to capital Z, or small a to small z, or it can start with an underscore. This is what we call an underscore. That dash which is a bit down is called the underscore. So we can either begin with a letter capital or small from A to Z, or you can begin with an underscore when you are writing a C identifier, and after that they can be followed by a 0 or more other letters or more other underscores or digits. Now C does not allow punctuation characters such as this @ symbol or each, the $sign, the percentage. They are not allowed to be used as the names of identifiers. C is a case-sensitive programming language. What does this mean? In C programming, when you write this word manpower and this other word manpower, they are very, very different. Why? Here you are using capital M, and here you're using the small m. So these two words are different, and C will recognize them differently. Why? Because C is a case-sensitive programming language. So here we have some examples of identifiers, some correct names of identifiers that can be used in C. Now let's talk about keywords. Keywords are words which are known to the compiler. These words are reserved and may not be used by a constant or a variable or any other identifier. So you cannot use a reserved word or a keyword as a name of an identifier. So the following list shows the reserved words in C. You will go through them. We have another exercise that I want you to do, not just to try out. You know, some person said that trying is the first step in failure. So I urge you not just to try, but to do these exercises. So make some research. What are the properties of keywords? And write any 32 keywords with their meaning in C programming. Now let's talk about the white space in C. A line containing only white space, possibly with a comment, is known as a blank line, and C compiler totally ignores it. The white space is the term that we use in C to describe blanks, tabs, new line, and some other characters and comments. The white space separates one part of a statement from another and enables the compiler to identify where one element in a statement is. For example, if you have the words int, when you put a white space, it shows that that word ends from there. So in this example, you are seeing int, white space, age. Even if you use a tab, you use the space key, or you use many spaces, doesn't matter in C. But as long as you put a white space, then it shows that these two words are different and it separates the two words. So there must be at least one white space character, usually we use a space, between int and age for the compiler to be able to distinguish between them. Now if we continue and you look at this statement in C, you are seeing fruit and then white space equal to white space, apples, space, plus, and so on. So this is a comment. Here we are terminating, and the comment is trying to explain what's going on, that we are getting the total fruit. Now note, no white space characters are necessary between fruit and the equal to sign. This space here between fruit and the equal to sign, we are saying that it's not necessary, or between the equal to sign and apples, this space here is also not necessary. But again, you are free to include that space for the purpose of readability. So in order that your code may be readable and clear, then you can put that white space. But when it comes to execution, that white space is not necessary. But now, as we have said previously, when you have int age, then that white space for that scenario is necessary. Let's talk about data types. The kind of data that the used variables, constants, or functions can hold in a programming language is known as the data type. The type of a variable can determine how much space it occupies in the storage. For example, if the variable is int, if it is a string, if it is a character, that type of the variable, the kind of the variable, will determine how much space it will occupy in storage and how the bit pattern stored is interpreted. So in C programming language, data types are classified as follows. So we have what we call the primary data types. At times we call it the basic data types or predefined data types. 2, we have the derived data types or the secondary data types or user-defined data types. Then you have enumeration data types and then the void data type. So still this tree diagram tries to show each data type and some description or more other types under each data type. So you will go through them. Then we are going to look at the primary data types. So under primary data types, we have the integer, floating point, double, and character data types. So this is also trying to show what each entails. the integer can either be signed or unsigned, int, short, long, and so on. Then the floating point data type can also have varieties, as in float, double, and long. Then the character, we use the char. It can be a signed char or unsigned char. When you talk about signed char, signed int, signed short int, signed long int, signed means it has a negative sign. Unsigned means it has no sign. In other words, it is positive. Let's talk about the integer data types. The integer data type is a set of whole numbers. Every integer value does not have the decimal value. So an integer is a whole number with no decimal value. We use the keyword int, this word int, to represent the integer data type in C. We also use that keyword int to declare the variables and to specify a return type of a function. So declare means to introduce that variable or anything. To declare, you are introducing it to the compiler. So still the int keyword will serve the same purpose. The integer data type is used with different type modifiers like short, long, signed, and unsigned, as we have already noted. This table provides a complete details about integer data types. So you will go through them, but note this is the size in bytes that is stored in memory. Then these are the types under integer data types, and these specifiers are very important for us, most especially the programmers. When we are programming, we shall see that we use a specifier for each data type, the %d, that %u, depending on the type of the data type. Now we have floating point data types. Floating point data types are a set of numbers with the decimal value. So unlike the integer data types, the floating point data types have decimal values. Every floating point value must contain the decimal value. The floating point data types have two variants. So we can have the float and the double, and even times the long. So we use the keyword float to represent the floating point data type, and the keyword double to represent the double data type. The floating point data type and the double data type are similar, but they differ in number of decimal places. So for the floating point value, we shall have 6 decimal places, that's the maximum, whereas the double value contains 15 to 19 decimal places. This table still provides a complete details about floating point data types. These are their different sizes, and these are the specifiers. So remember, for integer we used %d and %u for signed integer. For the unsigned integer, %d and %u. But now for the floating point, we have %f as a specifier for the floating point data types, then %ld for the double, and %still ld as the specifier for the long double data type. What about the character data type? Character data type is a set of characters enclosed in single quotes. When you have a character enclosed in single quotes, that kind of data type is called the character data type. So this table provides complete details about character data types. You are seeing the specifier for character data type is %c and C for unsigned, and even for the signed. Now this table here provides the complete information about all the data types in C programming. You will go through it in your time. Let's talk about these remaining data types. We have the void data type. The void data type means nothing or no value. Void, nothing or no value. Generally, the void is used to specify a function which does not return any value. So just like we said, when we are creating a C program, we use the int main, and that main is the main function. It has a data type of int. Now instead of using int, in most cases the main function may not return any value. You can just use the word void, and when you use that word void, there is no need of using the return 0 statement. So we also use the void data type to specify empty parameters of a function, as I've already explained. Then we have the enumerated data type. An enumerated data type is a user-defined data type that consists of integer constants, and each integer constant is given a name. So the keyword enum is used to define enumerated data type. We have derived data types. The derived data types are user-defined data types, or we call them the secondary data types. In C programming language, the derived data types are created using the following concepts. So we can use the concept of arrays, structures, unions, enumeration to create the derived data types. So it's the user to define them, and that's why they are called the user-defined data types or the secondary data types. Let's talk about variables. Variables in C programming language are the named memory locations where the user can store different values of the same data type during the program execution. That means that the variable is a name given to a memory location in which we can store different values of the same data type. In other words, a variable can be defined as a storage container to hold values of the same data type during the program execution. These are the rules to specify a variable name. So these rules are followed when you want to name a variable. The first rule is that the variable name should not start with a digit. Remember, variables are keywords, so all rules that must be followed when you are naming or creating keywords, not keywords, identifiers, all the rules that apply for identifiers still will apply for the variable, because the variable is an example of the identifier. So that's why we are saying variable names should not start with a digit. And number two, keywords should not be used as variable names. For example, the word int is already known to the compiler, it's reserved. The word enum, the word const, the word float, the word double, all those words, the word main, cannot be used as variable names. Why? They have a certain reserved purpose they should serve to the compiler, and that purpose is already known by the compiler. Number three, variable name should not contain any special symbol except the underscore. So that dash we said is the underscore. Symbols like question mark, symbols like the $sign, symbols like the hash, all those cannot be used as variable names. And number four, we are saying that the variable name can be of any length. So whatever kind of length you want But remember, the compiler will only use or consider the first 31 characters of the variable name. So if you write any variable name which is beyond 31 characters, you are wasting your time, because the compiler will only consider the first 31 characters. But again, my friend, it's awkward to write a variable name which is even 20 characters, because that's not something easy. It's better to use variable names that are easier to remember. So to go beyond 31 characters is abnormal. Declaration of a variable. Declaration of a variable simply tells the compiler to allocate a required amount of memory with specified variable name, and it allows only specified data type values into that memory location. So in C programming language, the declaration can be performed either before the function as the global variables, or you can even declare inside any block or inside any function. But all in all, it must be at the beginning of the block or at the beginning of the function. So this is the syntax for declaration in C. When you want to declare something like a variable, you begin with its data type and then the name of the variable. So that's the syntax. Now, this is an example of how to declare a variable. When we say int number, what does this mean? Int is the data type to represent integer, and this number is the name of our variable. So here we are declaring a variable called number, and this variable is of an integer data type. We are using this white space to separate this keyword int and this variable name number. Note, int here is a keyword. It's already known by the compiler. It serves a purpose of telling the compiler that what follows after int is a variable, or is a variable, or any identifier of an integer data type. So it's a reserved keyword. But this number is user defined. It's the user who can name this variable depending on what the variable is going to do. Let's talk about constants. Remember, we have talked about variables. As in the word variable, you can sense that something changes, varies. But now constant, something does not change. So the constant is similar to the variable, but the constant holds only one value during the program execution. This means that once a value is assigned to the constant, that value cannot be changed during the program execution. Once the value is assigned to the constant, it is fixed throughout the program. How can we create constants in C? Constants can be created using two concepts. One, we can use the const keyword, or we can use the define preprocessor command. So when we are using the const keyword, this is the syntax. You begin with the keyword const, then the data type of that constant, followed by the constant name. Remember, for a variable, we don't use the variable keyword, but we just begin with the data type and then the variable name. But for a constant, we begin with the const keyword. So this is an example. Const int x, then we assign it a value of 10. As we shall note, this equal to sign is an assignment operator in programming. The equal to symbol, we always use the double equal to signs. So here assigning means x is not equal to 10, but we are giving it a value of 10. We are assigning it a value of 10, or we can say that this constant x, which is of an integer data type, is assigned an integer value of 10, then we terminate using the semicolon to show the end of that statement. And now, to use the define preprocessor command, we shall do that using an example. So let's open our code blocks program, and we are going to create a simple program using that code blocks to try to explain how we use the preprocessor command and try to see how the variables and constants work. Okay, let me hope you have opened your code blocks. You'll follow along. Okay, now those of you who have tried code blocks, I told you as your assignment to download it and install it and configure it for use. At this point, let me hope you know how to create a project, you know how to save a project, you know how to open it, how to transfer it, and so on and so forth. But as you noted, if you did that assignment, you can create a new project using this link here, or you can go to File and then you go to the New and then click on Project. So both ways they do work. Now the projects that we are going to be using are called console applications, so we choose the console application and then click Go. Then we just click Next. Now here you can see that you can select the language that you want to use, but for us we are studying C, not C++, so you choose C and click Next. Then here you put the title of the project. For example, we are looking at constants, so we can call our project constants. The moment you write the project title, by default the project file name will also be similar, and it will have this extension of CBP. Now the folder to create the project in, you can choose any folder that you set aside where you are going to be storing your projects. So for me, I created a folder in documents and I called it C Programming. So this is my first Hello World program that I created. Now I select that folder and then click Next. The rest you just click Finish. That means you have succeeded in creating your project. Now after that, here on your left you have this window or this menu, this area which has projects, symbols, files, resources, and so on. So you always go to your projects, then when you expand these constants and go to sources, you double click on that main.c. That is where you write your source code. So by default, this compiler will write for you a default Hello World program, which we shall edit, and then we run it after we have edited it. Okay, so let's continue. Now I'm going to edit this. We already have the include stdio.h and the include the standard library.h. You can leave it there. Then we have the main function, and this shows that we are opening the main function and then we are closing the main function. We have the printf, hello world, and the return 0. So this time let's change the int and we use the void. Okay, void main, that means we shall not need the return 0. So let's create a variable, an integer variable. So we use int, then I, and we assign it a value of 9. and we terminate. Then we create a constant, const, as we said, int. Our constant is called x. Then we assign it a value of 10 and we terminate. Now if we happen that we want to change these values, I is a variable, so instead of having the value of 9, which is its initial value, we can give it another value like 15 and then we terminate. Again, x is a constant. If we try to assign it another value like 100, since x is a constant as we declared it, when we try to give it another value of 100, it will have to create an error because it's not allowed. So let's put a comment that this will create an error. So it creates an error. And our printf, we can print these values. If our program is successful, we can print I equal to, then we have percentage %d. Why are we using percentage %d? I is an integer, so we use percentage %d because percentage %d is the specifier for an integer data type. So that specifier is just taking the position where our value stored in variable I shall be displayed. So in this position where you are seeing percentage %d, that's where our value will be displayed, which value we expect 15, the last value stored in I. Now we can use the /n. This slash is always the backslash to take us to a new line, and on a new line we also print x. Then we expect the value of x. Now this x is also an integer constant, so still we use the same specifier, percentage %d, and then we close we close the quotes. These first quotes shouldn't be there, so we close the quotes. After enclosing that string in quotes, we put a comma and then we put I comma x, then we terminate. So after putting a comma, you put I and x. That means you are calling the value that is stored in variable I to be displayed where this percentage %d specifier is. So in the position where you have this another percentage %d specifier for integer constant, you will display this value of x. But as I told you, expect an error. Why? We are changing the value of a constant, yet a constant, as I've said, must remain the same, unchanged during the program execution. So here we can run our program. Now whenever you run a program, the project has to be built first and then it is run. So when we say yes, you see that red shows that we are receiving an error. We are getting an error because we are trying to change the constant variable value. That is, we are giving x another value of 100, yet x is declared as a constant. I think we are together. Now, in order to fix that error, we can either change this x to be a variable, or you can just ignore this line and then we leave it the same and we don't tamper with it. So let's try both. When we change the const, now our x is a variable. Now when you run again, it has to build and then it will display. So this is what it displays. It is saying I is 15 and x is on a new line because of the /n, and it's 100. So since x is now a variable, it can change the value assigned to it, and that's why our program runs well without any error. Another solution, as you have noted, is to leave the constant as it is, and if we comment out this, that means this line will be ignored. So we shall only change the value for I, and the value for x, since it's constant, will remain the same. Now when you use this button here, it does both. It does the build and the run. Now if I run again, I will get the same results as before. I is 15, x is 100. Why? Because I'm just building and run. I'm just running, but I'm not building. So here, when I do build and run, that means I'm making the changes that I've made, and again after which I execute or I run. So I prefer using this whenever I make the changes. So let's try it. So when you click it, you get this. I is 15. You see, I is 15. It's changed from 9 to 15, whereas x is 10. Why 10? We have ignored that line that was changing the value of our constant. Okay, let's continue. Now, another way of defining a constant, as you have said, is using the define preprocessor. So we can also create constants using the define preprocessor directive. When we create a constant using this preprocessor directive, it must be defined at the beginning of the program. That is because all the preprocessor directives must be written before the global declaration. So the syntax is as you see it. You begin with the define keyword, and before the define there is that hash symbol, then constant name, and then the value of the constant. So here we don't use the assignment operator, just like in this example when we say define pi and then we give it a value of 3.14. So here we are defining, we are declaring a constant called pi using this define preprocessor directive, and we are assigning it a value of 3.14 without using the equal to the assignment operator. So here this pi is a constant with a value of 3.14. Let's try out this example. I'm going to use the same program and then I modify it. Okay. So now here, since this is a preprocessor command, it must be defined up before this main function. So we can write that define, and then we have pi. I'm using capital P, capital I. Then I put space 3.14. And here in these preprocessor commands, we don't terminate. Now here I can have int. This time let me use the R and area. So you have two variables, area and R, which means of course the radius. Then we terminate. Okay, we can have our printf function. Printf, let's tell the user to enter the radius of the circle. So we can say, please enter the radius of the circle, after which we terminate. Then we use the scanf function. This is an input function that will capture what the user enters from the keyboard. So when you use scanf function, we use the specifier of the variable that will store what the user is going to enter, and we are using D because our variable r is an integer, and we are telling the user to enter the radius, which radius should be an integer. Then comma, we also want that that value that the user has entered to be stored in R. So to tell C that this integer that the user has entered should be stored in variable R, we put a comma, and then we use the ampersand symbol, or which you call the and symbol, but the correct name is ampersand, then followed by the variable R. We terminate. Now we can assign area using the, you know how to calculate the area of a circle. It is pi r squared, meaning pi times radius times radius. So here we can show that using pi, that is the pi. Remember, pi is already declared and given a value of 3.14, times we use that asterisk symbol, or what we call the star. We can use the brackets times r, that's radius, squared means r times r. So again, times r, and then we terminate. Then we can display the answer using the output function printf. We shall of course terminate. So we can write this string telling the user that area of the circle is, we can use equal to sign. Now where we shall display the area, as we have been doing, we put the specifier. Since this area is an integer, remember the radius captured is an integer, and we declare the area as an integer, so we expect an integer answer. So we use the integer specifier %d, and we put a comma, then we write the variable that is storing the value, which value we are going to display in this position of the specifier, which variable is area. Then we terminate. We don't need to return 0. Why? We have already used the void telling the function, the main function, to return nothing. So since we've made changes, we can use the build and run button. So when we click, it is telling me that I have an error somewhere. So let me check. Well, you see, in programming it's very easy to do an error, or to make an error. Now when you look at the messages, they are telling me that undefined reference to print. Now at times when you don't have experience, these error messages are not easy to interpret, but with time you will learn how to interpret them. But now when you look at this, I'm using a function which is not known. The function is printf, and I'm using print. So when I add f and I build and run again, now my program should be able to work. So this is the window. Please enter the radius of the circle. So I put 5. When I press enter, I get this the result that the area of the circle is 78 kongs. So we have created our program to calculate the area of the circle by telling the user to enter the radius. Sometimes you may be asked to write a simple program like that to calculate the area of the circle, or they can write for a program and tell you to explain the program or to tell the purpose of the program. So in that program, the purpose of this program is to calculate the area of a circle by capturing the radius of the circle from the user. Now note, this word is supposed to be defined, not define. It is N before E, so you correct that. Yeah, let's continue with escape sequences. Escape sequences. Now sometimes it is necessary to use characters which cannot be typed, or characters which have special meaning in C programming. For example, you have the new line, the enter tab, and the question mark. So in order to use these characters, we have to use the escape sequence. The backslash, that backslash is what we call the escape sequence. It causes the escape from the normal way the characters are interpreted by the compiler. So whenever you put the / before character, it causes an escape to the compiler so that it interprets it in another way other than the normal way it's meant to interpret it. So here we have some examples of escape sequences. You'll read about them, and that table also shows other examples. Okay, as we are winding up our lesson, let's look at the expressions and statements. An expression is any legal combination of symbols that represents a value. Each programming language and application has its own rules for what is legal and what is not legal, or what is illegal. For example, in the C language, x plus 5 is a correct expression, and so is the string of characters monkeys. On the other hand, a statement is a command given to the computer that instructs the computer to take a specific action, such as these actions. For example, an action to display something on the screen, an action to collect the input. Now, a computer program, as we have seen one, is made up of a series of statements. Now, a statement is a combination of symbols. A statement is a combination of expressions. When you have different expressions like x plus 5, monkeys, for example, you can say monkeys and use the assignment operator x plus 5. That is now a statement. So you have expressions combined to formulate a statement. And now, when you have several statements, you formulate what we call a computer program. So it is the computer program that we execute to do a specific task. Friends, this marks the end of today's lesson. Remember, hard work pays. God bless you. Don't forget to subscribe to my channel, and don't forget to invite more friends of yours to come and enjoy these tutorials about programming concepts in C. Good day.